All right, so this video will go over the concept of volume that you need to know. Um, we have many formulas for finding volumes of various solids. These are not formulas that we're going to make you memorize because pretty much anytime you would need to use them, you would just be able to look them up anyway. Um, the difficulty in using these comes from being able to find sometimes like the height or the radius or various measurements of these objects. So giving you the formulas is not a big thing. The only thing I'll put spheres on the next slide. So you need prisms. Okay, so prisms are shapes like these that have a base and another identical base connected by rectangles. Okay, so this would be an example of a triangular prism. This would be an example of a rectangular prism. But you could have a pentagonal prism or a hexagonal prism. Right? Any kind of shapes could be connected to make a prism. You have what are called pyramids, so-called because that's what they look like, right? Like the pyramids in Egypt. They also have a base, but rather than have another base that is connected to it, what you do is you just take all the corners and connect them at a single point at the top. And then, of course, we have cylinders, which are soup cans, and then we have cones. And we also have spheres, which I'll do on the next slide. These are the formulas, and I'm going to go through some examples of how to use them. All right, so the easiest example, of course, is just a box. Length times width times height. You probably did this in middle school at some point. If you were trying to calculate the volume of this thing, you would simply use the dimensions that are given. 8 by 14 by 6. Let me get my calculator open. And you would multiply that out and get 672. Okay, the unit, if this is in inches, volume, right? Always in inches cubed. So we use cubic units because, again, you think of like breaking this into a bunch of tiny little 1 by 1 inch cubes, and you're asking how many could you fit in this box. So we could fit 672 of those little cubes. Okay, a little bit harder would be a triangular prism. The formula for the volume of a prism is the area of the base times the height or the length if it's laying down. Okay, so in this case, we'll assume that's a right angle. They are giving us everything we need to solve this. So the area of the face, well, that's a triangle, right? So it's just 1/2 base times height. And then, of course, the length is 7. And then we would calculate that out. So that's going to be 6 times 7 is 42 feet cubed. Now, how could we make this more difficult? Well, maybe they don't give you the height, and you would need to solve for the height using, Pythagorean theorem or trigonometry or something like that. Okay, just a concept that we need to be aware of when we're doing volume. When something is slanted, it does not change the volume so long as the shape has the same cross sections. So in other words, if I take this box that's 4 by 40, or sorry, 4 feet with a base that's 40 feet square, excuse me, and I imagine taking a box with the same base but sort of shifting it, right? So like this stack of books here is meant to illustrate. You can imagine like pushing the books over. Now, you end up with a slanted box, but the volume of this box is the same as the volume of this box. You didn't add any books, you didn't remove any books, so it's taking up the same amount of space. Okay, that's what we call this Cavalieri's principle. It just says that these two things are going to have the same volume. So in other words, to calculate this box, you're going to do the same thing you would do for this box. So you would do 40 times 4 for this one. You were also going to do 40 times 4 for this one. Okay. So for instance, this cylinder, okay, a normal cylinder looks like this. And this is the formula, pi r squared h. Okay, well, even though this is a slanted cylinder, we can still do the same thing. Pi, they're giving us the radius, and they're giving us the height. Now, height goes straight from the top of the thing down to the bottom, or down to the base, rather. Okay, and then when we clean that up, and let's just use our calculator, 15 times 36, 540. Please leave the pi. Right, leave it in exact form. And this didn't have a unit, but let's just say that was centimeters. This would be centimeters cubed. Just because it's slanted doesn't change anything. We can also think now about more complicated situations, okay, like hollowing out a shape or building two shapes on top of each other, right? Like you can imagine having a box with a sphere put on top or something. All right, well, how would you do this problem? Okay, well, first of all, let's think about the box. Now it's slanted, but that doesn't matter because, again, I have the height and I have all the dimensions, so the volume of the box is just going to be like we always do. And then the cylinder, right, is hollowed out, is taken out of this thing. So we're just going to subtract the area of the cylinder, which again is pi r squared h. They're telling us 8 is the diameter, so 4 squared. And then the height, well, the height of the cylinder is the length of the box, so 30. Right? And whatever that, simplifies out to, that would be your answer. Okay, so we can add volumes, we can subtract volumes in the same way that we add areas or subtract areas. All right, where things can get a little trickier is something like this. You're given a pyramid. The volume for a pyramid is almost like a prism, but we multiply it by 1/3. Okay, but you need the height of this thing. They're telling us the base is a square. So the area of the base, that's easy. Okay, that's just 14 squared, or 14 times 14. But we don't know the height, not yet. 25 is what we call the slant height, because it goes down the sloped side of the pyramid. But when we talk about this height, what we want is this dotted line right here. Okay, going straight from the top directly to the bottom. Well, so how do we find that? Okay, well, this is, just a little bit of being clever. We think about, hey, if I drew a line from here to here, if you can imagine for a moment in 3D, that makes a right triangle. And this is a square, so this is going to be like halfway. So if this is 14, this will be 7. So I can solve for that missing side using Pythagorean theorem. And then if you solve that out, this one works out nice, you end up getting 24. Okay, so 7, 24, 25. And so that is the height of the pyramid. And again, whatever that calculation comes out to, that would be your answer. All right, one final example. This is a cone. And it looks like it would be tricky, but actually they give us everything we need. The volume for a cone is 1/3 pi r squared h. And so we would set this up, 1/3 pi, the radius. Now the 6 is the whole diameter, so we just want the radius. And the height is 6. Okay, even though it's slanted, again, Cavaliere's principle says that doesn't matter. And that's going to work out to 18 pi. And again, if this were feet, this would be feet cubed. Did I do that right? 18 pi. Okay. One thing I just realized we didn't go over earlier was spheres. So the volume of a sphere, again, you're not going to memorize these formulas. You just need to know how to use them, is 4/3 pi r cubed. And so, you know, if you had a sphere with a radius of 5, you would simply say 4/3 pi times 5 cubed. It's just as simple as plugging in the radius. Right, so that's pretty much all you need with volume. There's an assignment on Canvas if you want to go try it. Let me know if you have any questions, and I'll make another video for surface area. Thanks for watching.